All right, hello everyone, this is Mr. Crozier. I'm going to help you with Chapter 6, Practice Test number 1. Here we go. First problem, find the inclination of a line. Well, if this is our line, of course, we have to put it in y equals mx plus b form to get a good picture of it. Move these over here. Say negative root 3x minus 2. Divide everything by negative 1. And there we go. So now what we do is find the inclination here, and we have one formula to remember. It's kind of an easy one. The tangent of theta is equal to the slope, because if you draw a line, the slope is rise over run, which is opposite over adjacent, which is tangent. So I have tangent of theta is equal to root 3, and now all I need to do is inverse tangent that. So tangent of theta is inverse tangent of root 3. Grab my calculator. Let's make sure it's in degrees. I'm going to put it in degree mode here, and inverse tangent of square root of 3 and 60 degrees. And that should make sense because root 3, that was a tangent value on the unit circle, and 60 degrees is pi over 3. Now you can always graph this to make sure. I'm going to go ahead and do this on here. I'm going to hit y equals, and I'm going to graph this line here. You can do it by hand, but I have a calculator here. So I'm going to graph the line with a slope of root 3, hit graph, and there's the line, and that angle does look like it's 60 degrees right there. So again, that's what we're doing. An angle of inclination is when you have that line, that angle going up does look like 60 degrees. All right, number 2. Find the angle between these two lines. Well, this formula is a little bit more complicated. It's tangent of theta equals the two slopes subtracted over the addition of the two slopes when they're multiplied together. All right, well, we've got to find the slope. So what would this be if I found the slope? Well, if I put that over there, I'd have 2y is equal to negative 5x plus 16 divided by 2, and there's line number 1. And put this over here, that's negative 5y, negative 3x minus 1, divided by negative 3. And there is slope number 2. Well, I'm subtracting slope 2, so I'm going to make this one slope 2, and I'm going to make this one slope 1. Doesn't really matter because I'm taking the absolute value. And we have the tangent of theta is equal to them subtracted, so 3/5 minus a negative 5/2, well, that would be plus 5/2. And down here, I'm going to multiply them, and I have a negative 15/10. All right, common denominators in the top are 6/10 plus 25/10. Common denominators in the bottom, 10/10 minus 25/10. And what do we have here? 31/10 over negative 15/10. I'm just going to call it 15/10 because, well, 5/10. How did I switch that? It's still 15. And now we have 5/10 here. And when I simplify this, I'm going to have the tangent of theta equals times top and bottom by 10. And I have 31 over 5. And I went ahead and made it positive here because this is all in absolute value. And now all we have to do is the inverse tangent. So let's see here, inverse tangent, 31/5. And that's 80 degrees. 434 degrees here. And a lot of them say turn it into radians, so I'm going to go 80.44. degrees times 100 times pi radians. So I'm going to take that number, times it by pi, and divide it by 180. 1.4109 radians. All right, and again, I'm just finding the slope between the two lines. You could graph them, you're going to graph them, and you're looking for that angle between them. All right, going on here, number 3, find the distance. Well, the distance formula is just ax plus by plus c, absolute value all over a squared plus b squared. So first thing I want to do is transform this into the right form, and that's going to simply be 4x minus 5y plus 2 is 0. All right, the distance equals 4 times the a point minus 5 times the y point plus 2, and that's absolute value. And at the bottom, square root of a squared, which is 4, plus b squared, which is negative 5. All right, so the distance is 4 times 2 minus 5 times negative 3 plus 2, 25 on the numerator, and the denominator, 4 squared plus 5 squared is root 20, or 41. And the distance is simply 25 divided by square root 41, about 3.9043. Or you could, of course, make this an exact answer, or rounded, whatever it asks for. All right, on the last problem here, or problem number 4, identify the conic. Well, 1 squared, 1's not. It's definitely a parabola. I'm going to sharpen my pencil real quick. And put it in standard form. Well, we have to complete the square. I'm going to add a perfect square there. And everything else goes to the other side. Well, what is the perfect square I need? Well, half of it is 1. Squared is back to 1. Again, that's b squared over 2 if you don't know that value there. And I added 1 to the left. I'm going to add 1 to the right. And this would be negative 8y minus 8. Almost done. One last step. Factor out this negative 8. And we have plus 1. All right. We're ready to graph. Let's talk about what we know. We know the center. Center is at 1, negative 1. 1, negative 1. I've already done this problem, so I know it'll work if I count by 1. So there's my first value, my center. And now let's talk about the axis. Well, that's an easy one. That's this line that goes right down the middle. And what I see here is that it is a y equals x squared parabola. So it's a regular up or down parabola, but it's negative, so it is down. So it's going down. So this axis goes right through this point right here. This is the axis. Now if I have an axis, I always have a directrix. And I have a focus. And a focus is a point. And a directrix is a line, and it's the opposite of this one. So what is it? Well, we have to talk about how much the directrix and the focus move from this center. Well, they move by an a value divided by 4. So they move by negative 8 over 4. They move by negative 2. So if this is my center, my focus is down here, and my directrix is up there. So I'm going to go over these lines a little bit better so you can see them. Here's my center, here's my directrix, here's my axis, there's my focus. So what is the directrix? Well, it's the line y equals 1 because it's 1, 2 spaces up. That's at 1. What's my focus? Well, it's 1, 1, 2, 3, negative. All right. Well, the last thing we need to do is get some very good points on here. And the way we've done in this class, so we talked about an input and an output. And an input and an output table for a quadratic is simply where I square them. So this is what normal looks like. However, it's not normal. We divide by a. A value is here, but if I wanted to make it affect this over here, I would divide it over. So I'm dividing by negative 8. Go ahead and put that there. And if I divide all these values by negative 8, these are the ones I come up with. So now I can use them to plot it. I start here, I go over 1, and I'm not going to use these ones anymore. I'm going to go over 1, down 1/8, over 2, down 1/2, over 3, 1 1/8, over 1, 2, 3, 4, down 4, and that's a key point right there. 1 1/8, 2 1/2, 3, 1 1/8, 4, 2, and there's a good parabola. So those are all the parts of your parabola. Again, a couple formulas to remember here. This is how it moves, and this is how it changes, and there's your formula for standard form. All right, hope this helps with the problems. If you have any questions, please ask.